Everyone. In this video, we are going to cover all the related aspects of 5G downlink demodulation reference signals. Actually, 5G is more relying on DMRS whenever the user is trying to estimate the propagation channels, and according to other reference signals as well, like such as CSRS and so on. But unlike the 4G, which is mainly relying, if you remember, on the cell-specific reference signals to estimate the propagation channels, and the main advantage for the 5G over the 4G in this part, that the CSIRS cell-specific reference signals was always on, if you remember, it was all the time being transmitted, while for the DMRS it's not the same case. That's why it's having less overhead and even it's having better demodulation. And I have covered some of these parts in my video, which is other videos, remember, for 5G versus 5G differences and so on. So let's move forward to see what we'll cover today. Okay, so today actually what I'm planning to cover here, we are planning to cover all the types of the DMRS for the downlink for the 5G. First one is DMRS for BDSH, then for broadcast channel, then the last one would be about the BDCH. The last two is kind of like straightforward and like kind of easy. However, in DMRS for BDSH, we have many parameters and configuration, which is usually making a lot of confusion. I'll try to summarize this one in one slide and we try to go through all the aspects just to make it very clear for everyone. And in case if you want to jump into details, I have given some of the details after the summary slide for the BDCH related configuration. And we will be ending by these two DMRS for broadcast and BDCH, which is kind of straightforward and easy. So let's move forward now. So the first part here in this slide, which I'm going to try to cover, you can see here I have covered some parameters, which is in the left side. Then you have some kind of BDSH DMRS configuration and so on. But before jumping into this, before explaining each and every single of those mentioned parameters or the configuration, I just would like to recall the knowledge about the DMRS and 5G in general, right? If you remember that the first thing that the DMRS is being used by the UE to estimate, as I mentioned here, the propagation channel experienced by the BDCH, or if you're speaking later on about the BDCH or broadcast, so that the DMRS will be using to estimate the propagation channel about the BDSH. This is the first part. The second part, that's about that, as you know, that DMRS is only associated all the time with the BDCH. You cannot have DMRS as long as the user doesn't have any BDCH in the channel. That's why it's called BDCH is always transmitted in a combination with the DMRS, and both use the same antenna boards and so on. And actually, what I won't say that the DMRS is transmitted within the same set of source blocks allocated to the BDCH. What it means by this? It means, for example, if you have 10 resource blocks being used by BDSH, so the DMRS also will be using 10 resource blocks, cannot be more, cannot be less. So it will be all the time transmitted within the same set of resource blocks used by the BDSH. The last point I want to cover here that, as you know, this is what we are going to cover now. There is kind of you can when you read the documents or the whatever training documents you have usually kind of configuration confusion about the configuration. As you can see here, we have many configuration, and the BDSH GMRS actually configuration depend upon those variables and even more. And this actually configuration it's account for the single user MIMO and multi-user MIMO requirement for DMRS. This point it will not look clear, but actually whatever we do here, whatever we tune in the network can improve even the performance of multi-user MIMO or single-user MIMO. So that's why we need to understand really what is the differences between all of these configuration and how to use it to optimize or to tune the network things. So now let's go through one by one. But before jumping to this part, I have covered here one of the main configuration of DMRS, which is having control at the end over the again frequency resource allocation or time resource allocation. The first three is covering about it's more about the frequency resources, how many resources will be allocating within the resource blocks for DMRS and so on, and the BDSH mapping type, which is having type A and type B, will be covering this part as well. This is mainly controlling the time domain allocations, and here this is the 3GPP parameters, and this is actually it's under your control. You can tune it in your vendor base. Depend for sure different from vendor will be different. You have the differences, but this is the 3GPP name, so you will find maybe different name in the vendor and so on. So now let's start. So in general, BDSH GMRS having four types of configuration as mentioned here. You have something called configuration type, then double symbol, additional position, and BDSH mapping type. So what it means by this? The first part here, configuration type. There is two types of configuration for the configuration type, which is something called type 1, and this is like controlling how many resource element will be used by the BDCH but sorry, by the DMRS within the BDSH. Assuming now you have one symbol of DMRS, so you will have 50% of these are resource element within this symbol being used for the DMRS. I will be trying to now to visualize this part to make it more clear for you. The second type, actually, it's called type 2, which is having 33% of the resource element. This is allocating every third subcarrier resource element, as I remember. And actually, there is advantage for both of them over each other. For example, this one have more dense of resource element, which is will give more advantage for more accurate estimation, while this one having less resource elements, so it will give advantage of multi-user MIMO, and I will be explaining this part why it will give more advantage for multi-user MIMO scope. So, okay, in general, both of them are using to control the frequency domain resource allocation. This is the main function, right? So now let's try to visualize to see what it exactly means by this, what we have just speak about. Speaking about the configuration type 1 as example, I mentioned to you, this is a resource blocks. This is the symbols and this is the subcarriers in the symbols. So we have 14 symbols and we have here 12 subcarriers. And as you can see, for example, the DMRS, and this is the BDSH, DMRS is being located in symbol number 2, 0, 1, 2. And as you can see, it's being allocated every second subcarrier. So it's consuming around 12 subcarrier out of 6 out of 12. So this means it's having around 50% of the resource elements. And there is more details about this part, but the main point or the main key point from here, that the more dense of resources here, this is means you will have more accurate channel estimation because you are giving the UE a chance to measure majority of the band and so on. So that's why it's having more accurate feedback if you're speaking about less dense of resources. So this is the first type. There is more details about this part. For example, here, the more you increase the REs, this is decreasing something called frequency scope, frequency multiplexing scope, and even code division multiplexing. This one I'll be covering in the next slide in details, in case if you want to understand more about this part. Secondly, it's about the configuration type 2. As you can see, was configuration type 1. This is now configuration type 2. As you can see, it's being allocated every third subcarriers, but it's coming with two REs as shown here. So you have more free resources and less resources used for DMRs. And as you can see that as accuracy point of view, the type 1 will be more accurate, but this one having a less number of DMRs being used. And this is actually giving a chance for this frequency multiplexing or code division multiplexing. And actually, the free resources which is mentioned for BDSH, this is can still be used for DMRS. So for example, assuming the first user is using this 2 or 4 RAs, second user can use the second to here and second to here. Third users can use here and here, but this would be frequency multiplexing within the same symbol. That's why it's giving more chance for frequency multiplexing. For example, I can here have 3 users with frequency multiplexing, while in type 1, I can only have one user, which is occupying this one. The second user will be equal, so I have 2 times only frequency multiplexing. Here I will have 3 frequency multiplexing. This is the main differences, but the details will be covered next slides. So as a summary for this part, the configuration type controlling the resource allocation within the symbol for the DMRS of BDSH or the DMRS for BDSH. Moving forward with the second type, it's about the double symbol. Actually, what we have shown to here just now for the type 1 and type 2, as mentioned here, this was occupying one symbol. Now, what if you want to double the configuration and make it 2 symbols? You have this parameter which is called maximum length. I believe you'll find within the same name or different name, the 3GPP name parameters. This one will increase the number of symbols here, so you can have additional symbol here, and this is accordingly can also increase the scope of frequency multiplexing or more about the code division multiplexing and so on. So the double symbol is being controlled by the maximum length, and this is actually the more symbols you'll have, this is means the more ports you will have. I'll explain this in details as well, and this will increase the scope of multi-user MIMO. So in case, assume that you want to increase the scope of multi-user MIMO, you want to have more paired users and so on. So you need to, for example, if you're using configuration type 1, you can increase up to double symbol. So this now means you are increasing the scope of multi-user MIMO because you will have more ports and more chance for code division multiplexing. I will try to visualize this one in upcoming slides and so on. So now this is how it looks like. This one I'm assuming I'm using type 1 here. Before, as you shown, it was using only one symbol. Now it will be using 2 symbols. So this is, you are giving more even resources and more channels, two different symbols. So increasing the scope of multi-user MIMO because you will have more ports, and also there's like you will have more symbols to be measured and so on. And for sure, this is increasing also the overhead, and this is one of the drawbacks. And increasing the overhead can impact your maximum user speed, because at the end this is like occupying overhead. Instead of using BDSH, you'll be using for the DMRs. Moving forward about the additional positions, actually, this is like additional symbol, okay? A double symbol. Instead of single symbol, double symbol. Additional positions means one, if you have one position here at this particular symbol, you can have different instance of symbols. What it means by this? Okay, first of all, this is just another example. Whenever you are talking about coefficient type 2, this is also double symbol. Now here about the additional symbols. First of all, the maximum number of symbols you can have uh, on top of one symbol, which is a single symbol. Uh, addition positions, I mean, you can have up to 4 positions, means up to 4 symbols. By default, it's only one. You can have up to 4. So the coefficient from 0 to 3, 0 means 1, 1 means 2, 2 means 3, and 3 means 4, and so on. So this is also one of the parameters we have, and this is usually important for the to improve the channel estimation in terms of high speed scenarios. What it means by high speed scenarios? Let's first try to see what we'll have here. This is, as you mentioned, this is additional position 0. So this means you have only one symbol. So what if I increase it to 1, for example? What will happen? You will see now that you have another instance in time, right, being used for this additional position. Even if I increase it to 3, you will have another one here, another one here. So we'll have four positions. So first point I want to highlight why it's first of all why it's important for the use channel estimation, and especially in the high speed scenarios. Okay, the main point about this part, if you know that in the high speed scenarios, usually the channel propagation, it changes very rapidly, right? If the users, for example, moving on a highway with very high speed, so the channel propagation will be moving very rapidly. So if you're assuming you have only one, you still have to wait to the other slot to start measuring this part. This is the first part, and his measurement maybe not be accurate because he measured here but he moved here, so that the feedback is getting already changed because you have different location. So actually increasing the position of this one will have a very huge benefit, because increasing the number of DMRS symbols, this will reduce the gap between the channel estimation, right? And this is also reduce the requirement for something called the wrong interpolations at the end, as I mentioned to you, that if you are moving in high speed, you will have a different radio condition here, so this will give inaccurate feedback. So that's why this is important for the high speed scenarios. And usually whenever we do testing for particular for decision positions, for example, we select the clusters where it's having a highway or high speed scenarios and start measuring this part, and it will give a very good improvement in terms of mobility or high speed scenarios. And also I need to add one important part: additional positions will consume overhead and also will impact your max speed. So you have to be very careful whenever you choose the scenarios where you are going to implement in this part. It's not recommended for you to be rolled out for the complete network. You can just choose areas or location where it's really required this kind of things. So the first three, as mentioned here, as you can see, we use mainly speaking about uh, more resources in the subcarriers, but also some of them was adding some slots. So it's also having some impact on the time domain as well. And now the last part, it's about the BDCH mapping type, and this is actually more relying on the BDCH. I will be covering this part in very details whenever we speak about the BDCH physical downlink schedule channel. But simply, this is what you do. You have two types of configurations. You have something called type A and type B. Okay, and type B, actually, if you hear this scientific term, which is called front-loaded, you will all the time what it means by front-loaded. Okay, so I will explain now what it means by front-loaded to make it more easy for you. But type B means actually that that front-loaded. This means that you will always, all the time, whenever you have type B configuration, that the first symbol of the BDCH will be all the time associated with DMRS. It's still not clear. Let's now try to clear it, but this one control the time domain resource allocation as mentioned here. Okay, as you can see in the figure here, this is, I'm assuming this is BDSH mapping type A. So you can see in this particular example, I have shown that the 14 symbols or within the slot is being all used by BDCH, but the DMRS is, like, as you can see, started at symbol 2, right? Start working at symbol 2. Okay, so what is the difference? This is type A, so type A can be starting in symbol 2 or 3, or it's having like a range of symbols to be start off. I don't remember the exact number, but I believe we cover in next slide. But however, it's not starting usually in the first. It can start at first, second, or third, whatever, zero, I think, up to 3. So this is the main idea of BDSH mapping type A, while mapping type B, it's all the time associated in the first symbol of the slots for the BDCH allocations. Okay, so now, okay, but there is one point I need to highlight here. That yes, okay, this is I usually allocate the first symbols here, and the main important point I want to highlight for you, that this one for sure will give advantage for the latency. advantage over. Why? Because here you have to wait for the third symbol until you start modulating your reference signal, right, for the for the DMRS, and start estimating the channel propagation for BDCH. While here you will directly be starting demodulating, and this will save time in the resource allocation, all these kind of things. That's why type B have more advantage over type A in terms of latency. So now let's now try to cover these three bars in more details. We'll try to make it quick. And in case if you are okay with this slide, you can jump directly into the broadcast channel and the BDCH channels. And next slide will be covering the details about this one. Okay, now let's try to go through more details about the configuration types. Okay, here again I give a quick comparison between configuration type 1 and configuration type 2. As mentioned before, configuration type 1 use more dense or more resources. Every second RE within the symbol will be used for DMRS. That's why it's occupying around 50% of the resource element occupying by the within this symbol for the BDCH will be used for DMRS. And this is if you are speaking about one user, but it can be even to up of 100% of the resources using different configurations or different ports and so on. And actually, this one using something single symbol. If you are speaking about single symbols, we're having around 4 ports, and, and if you're speaking double symbols, around 8 ports. Okay. Speaking about configuration type, as mentioned here, it's using every third subcarriers and having two symbols on this one, so it's having around 33% of the resource element being used by DMRS. And this is, as you can see, it's having more ports, antenna ports, like 6 ports and 12 ports. And that's why we mentioned before, it's increasing the scope of multi-user MIMO, scope of frequency multiplexing. And here in next slides, I will explain why this one having 4 ports and why this one can have up to 6 ports or even 8 or 12. This I will explain instead of like trying to memorize this part. You will really understand why it needs this one, what is the main requirement for this part. So this is just was quick explanation. And let's move forward now to try to cover why this kind of 4 ports and it. So now let's try to go more deep into the configuration type and why they have different number of ports. When you're speaking about, for example, configuration type 1, it's having 4 ports when you're speaking about single symbol, or up to 8 ports when you're speaking about double symbol. The same concept for this slide will be applied for configuration type 2. So that's why I covered only configuration type 1, so but it's having the exactly same concept. So for example here, assuming now, as you mentioned previous slide, we're showing that the DMRS, which is this one, is being occupying every second subcarrier, around 50% of the resource. So now let's speak about example for one particular user. Assume you have one user, single user MIMO using rank 1. So in this case, you will only require one port. So we can use only these resources, which every second subcarrier will port 1000. Now, assuming this user want to use rank 2. So in this case, he will require additional port. So he can use within the same resource element, but with something called code division multiplexing, having orthogonal codes. So in this case, he will be using an additional port with port 1001, and he start can getting rank 2. But as I told you, with code division multiplexing. And by the way, you have something called division multiplexing and frequency division multiplexing. Code division multiplexing is prioritized over the frequency division multiplexing. I'll explain more now about this part. So now assume the same user now, he would like to have rank 3. So now this means he before was rank 2 using 2 ports. Now you want to have one additional port, which is example port 1002. Okay, and this case, this one will be frequency multiplexing. We'll start using the free resources here for the frequency domain. So he will start making frequency multiplexing within the free resources here, and he'll be using port 1002. So now he will be able to have rank 3. Okay, so now same if you want to have rank 4. So now we'll be using code division multiplexing group 2 between these two port 1002 and port 1003. So you start using the same resource element within this resource element for the for the rank 4. So this port 1003 will be using here code division multiplexing, and it will start in multiplexing with this kind of ports. So in this case, the user will be able to use up to four ports. So why it's 4 ports again? Okay, as you can see here, you have only one free subcarriers, right? Every second subcarrier used, and the others are free. So that's why if you are speaking about, you have only two groups of frequency division multiplex and two groups of division multiplex. 2 multiplied by 2, it will be 4 ports. That's why the maximum as a single symbol can be used is 4 ports. While if you're speaking about the previous example, it was showing every third every thread that was coming here, if you remember. That's why you are having around 3 resources in between. So that's why we can have up to 6 symbols, 6 ports, because it will be around frequency multiplexing. It will be 3 multiplied by 2, which is code division. We will have around 6 ports per user. And here, if you are speaking about this part for the double symbol, now for the double symbol, we just increase the number of resource element here, and this is using port 1000, and this is actually increasing the chance to have more ports because you have more symbols here. More symbols means you can have more ports as well. So this one will double because you have double symbols. So it will double this one instead of using 4. Now it can be used 8 because now this is like you can say it also like time division multiplexing along with code division multiplexing around with frequency division multiplexing. And this is the main difference between coefficient type 1 and coefficient type 2. Coefficient type 2 will be exactly the same, but it will be 6 up to 12 ports, which is doubling the number of ports as we have just mentioned here before, because as you can see in the coefficient type 2, we have this kind of free in single symbol. So this one can be used for frequency division multiplexing, and accordingly can add addition code division multiplexing. And this is one increasing the scope. Whenever you have more frequency division multiplexing and code division multiplexing, this is increasing the scope of multi-user MIMO because you can now have more paired users. For example, if you're speaking a multi-user MIMO, not single user MIMO, which can have additional ports and can start being used more the DMRS to demodulate the signals in case of multi-user MIMO. So you can have more paired users whenever you increase the number of symbols, or even whenever you move from coefficient type 1 to coefficient type 2. And this is most about the coefficient type. So now let's speak about the BDCH memory type. As we mentioned before, we have type A and type B, and this is more controlling the time domain resource allocation when the user will be starting using the DMRS. As I mentioned before, type A can be located at even symbol 2 or 3 of the slots. So for example, here this is located at symbol 2, which is 0, 1, 2, and can also be at symbol 3. While type B is called front loaded because it's all the time being located at the first symbol of the BDCH allocation. But one important point, I think it was not clear in the previous slides, that the BDCH type B can have maximum up to 7 symbols for the BDCH allocation. Whenever you have type B, so it can have maximum up to BDCH allocated within up to 7 symbols, and this is the main difference. While this one can be type A can be up to the 14 symbols, but this one, as I mentioned, can give more advanced latency because it's all the time will be demodulating the BDCH within the first symbol, and this is good and faster to get resource allocated as soon as possible. This is the main difference. Okay, this part already covered also in the previous slides. For example, speaking about the additional positions, I just giving examples here. As mentioned before, this is useful for the high speed UEs because you will have more instance in time. So this can give better performance for the users, which wherever you have high speed, which is the channel propagation changes more rapidly to have better demodulation for the reference for the BDCH and so on for DMRS BDCH. So here, for example, as I mentioned here before, above here we have some high layer parameters which is define all the configuration for the DMRS. For example, here this is mentioned BDCH mapping type A, which we mentioned before. It can be starting at symbol 2 or 3, and this is the length of BDCH is being 14 length. So we're having all occupying all the BDCHs occupying all the symbols within the slots. Here it's mentioning the DMRS type A position, or starting position, starting symbol. It will be symbol 2. For example, this is type A. So this can be called starting symbol or DMRS type A position. So it means it will be starting at symbol 2, 0, 1, 2. And at the end here, this is mentioning additional position is 0. This means we don't have any additional positions. That's why the DMRS is only occupying one symbol here. Now, this is exactly the same example, but here just the main difference is this one showing as 1. So we'll have one additional symbol for the DMRS, and last one here it's about 3, and the 3 will be having up to 4 because you have the by default 1 and you have additional 3 symbols, so now you can have up to 4, and this is much better as mentioned before for the high speed UEs. And this is exactly the same, but I'm giving example for BDCH type B, which is maximum can occupy 7 BDCH can occupy 7 symbols. And here is just mentioned the DMRS type B position, which is B starting the first symbol of the BDCH. BDCH actually is starting from symbol 5, 0, 1, 2, 3, 4, which is 5, 0, 1, 2, 3, 4. Okay, and this is symbol 5. or symbol 4 in other words. And here we don't have any additional position. That's why we have only this part. And this differences will be additional position 1. So we'll have here additional 1. And this is 2, for example, we'll have additional 2 DMRS positions. And this is, again, can improve the performance for high speed use. And this is the main thing. Now, okay, now let's speak about the DMRS for broadcast channel. Actually, again, this is the same concept. It's used to estimate the propagation channel experienced by the broadcast channel. Okay, so this is the main thing. And as mentioned also here, the resultant information is used to simulate the broadcast channel, and accordingly you can decode the master information block. So this will be very useful in within the initial access. So now, how the resources are being allocated? So it's actually it's more easy because it's kind of having a fixed resources. It doesn't have a configuration to control the resource. So this you can say it's like more into theoretical things, which is not really can be used to tune something in our network. So how it looks like. This is how the SSP block in general looks like. In SSP blocks, it contains of 4 symbols, if you remember, and it can have up to 20 resource blocks. And if you are speaking about DMRS broadcast channels, so we need to focus on the symbols where we have broadcast channel. So as you can see here within the SSP block, we have symbol 1, 2, and 3, 3 symbols used for broadcast channel. All of these will be occupying DMRS. And in general, the DMRS is using only 25% of the resource element within the resource blocks. I'll be explaining on the right side. But just the most important information that I want to tell you, that the DMRS will be using 3 symbols, with symbol 1, 2, and 3. And even those is not all fully used by the broadcast. For example, the symbol 1 and 3 is using for broadcast. So this one will having 20 resource blocks, for example, used by DMRS. While in the symbol in between, this is having SSSS, which is synchronization signal block. And this one will be using only for the DMRS broadcast channel, will be using only 4 RB plus 4 RB, which is 8 RB. So in total, what we'll have this is the figure we have it. For example, if you're assuming now, let's assuming that this is different cells. I'm assuming now we have the first cell here, which is BCI, for example, 0. So now assuming that this is fixed location, the DMRS is being allocated within a fixed location within the symbol. So assuming now you are within the broadcast channel, so the DMRS will be allocated, as you can see here, every 4th subcarrier. And accordingly, this means it's only occupying 3 resource element within the symbol, which is mean 12 by 12. This means 3 divided by 12. This means it's only occupying 25% of the resource element. So if you want to calculate in general, in total, how it's being occupying, for example, you will have how many resource elements in general. So you can see here you will have 20 resource blocks, and each resource block will be using 3 for DMRS. So we'll have around 60 resource elements being used. And if you're speaking about the second symbol, it's only 8 resource blocks. Each will be using 3 DMRs. So in total, it will having around 24 resource elements. At the end, this is occupying 25% of the resources of the broadcaster channel. Okay, but the most important point I would like to add to you for the theoretical point of view, that the DMRS for it's relying on BCI mode 4. What means, for example, assuming you have four different cells, each is using different BCI. So this is how the DMRS will be allocating. The first one will be using BCI mode 0 or BCI 0. So it will be allocating in the first resource element, and it will every 4th resource element will be using here. So now this will be starting for the second position because it's BCI 1, and so on. This one BCI 2 will be starting for third position, then BCI 3, which is will be starting for fourth position, and so on. This is the main idea about this part. And as I told you, there is nothing to control about this part. Maybe just be considering within the planning, which is general planning in the beginning, to follow this kind of PCI mode 4 and so on. Now moving to the last part about this part, which is about for the downlink DMRS, it's about the BDCH, and actually it's more easy. I just give 3 examples here. This is whenever you assume you have only one symbol of core set being used, and the DMRS actually is using a fixed location, which is mentioned here, 1, 5, 9, which means 1, 5, 9, 13, 21, which means again every 4 subcarriers, and this would be over the complete bandwidth. So assuming the DMRS is using, for example, whatever 20 mega or 20 resource blocks or 50 resource blocks, DMRS will be available all the time, and will be having this kind of shift between the DMRS and the other, which is 1 to 5 and so on. And this is also occupying 25%, which is the same concept as the broadcaster channel for the BDCH. And this is actually that's it for today's video. And I hope if you like the contents to share it with your friends, and to press like and subscribe to the channel. Thank you, and see you in next video.